everyone, welcome to my channel. Today I'm gonna show you a couple of STAAD features that probably after you watch this video you're gonna use in a daily basis because they're quite interesting and quite important. For doing so, what I'm gonna do is to recover the first model that I created in this series. If you don't know what I'm talking about, then you should go to the video number 1 where I show you how to create this truss model. So I'm gonna start from this point. As I said, if you want to know how this was built, click in the link below and follow what is it said there. Good. So the two things that we're gonna study today are creation of groups. The creation of groups is interesting because it's gonna give you control on the results that you're obtaining. So for instance, in this truss that I have here model, I would like to know as a group to know the results of this series of beams here, this group of beams. Then as another group I would like to know the results of those groups of beams. Another group will be those ones, and finally another group will be those ones. Why? Because I'm going to be interested on which one of those, if apply the load here, is gonna suffer from it's gonna have the highest stress or the biggest moment, those kind of things. And the same for designing these beams here, because probably you're gonna design those beams to have the same cross section, these beams to have the same cross section, and those ones to have the same cross section based on the worst case scenario that you're analyzing. So I'm gonna start from that, and then the second part of the video is gonna show you how to create a mobile load. That's really interesting. Not only if you want to model, let's say, a vehicle that is running across or on top of your structure, it's to find what is the worst position of the load that causes the biggest stress in your structure or in your group of beams that you're analyzing. So that's a key feature that you have to know. Okay, let's start with creating a group. So I'm gonna go to Tools, Create New Group. Here I have to give the group a name, so I'm gonna call this upper beams. The type is gonna be beams. You can create groups for nodes and some other stuff, but in this video, well, I'm just gonna teach you how to use beam groups, and then if you let's say that you want to keep track of displacement of nodes, then it will be good for you to create groups for nodes too. But let's work with beams by now. Okay, group beams. Then I'm gonna highlight the beams that are gonna be that part of that group, those beams. Then I'm gonna leave this by default, associate to selected geometry, associate, and then here in this box here it appears the beam number of the selected beam. So if I nodes, no beams, I've just clicked Shift B to show the beam numbers. So as you can see, the list it's composed by 2, 7, 12 and 15, the highlighted beams. So now I'm going to create another group for the lower beams. Again, this is a beam group. I'm going to highlight this. To select multiple beams, what I do is press Control and then I click on the beams. Again, associate to selected geometry, associate. Another way to do it, I'm going to show you another way. Now I'm going to select those. I'm going to call them cross beams. Beam, okay. Another way is, if you know the beam number, as is shown here, you can define here the list. So it's 3, 8, 13. Associate. And now if you click here and highlight, yes, see? So whatever is easier for you. Then I'm going to create another group for the bracing. Again, it's a beam group, okay, and I'm gonna do it by selected geometry. Associate, easy. So now I have those groups. The results are gonna be grouped by those groups, and this is gonna make my life a lot easier while interpreting the results from STAAD, as you will see in a couple of seconds or minutes. Okay, let's close this. Now, after having created the groups, what I'm going to do is to go to the second part of this video, that is creating a mobile load. So I have gone to here, load page. I'm going to click first in load case details. I'm going to add. I'm going to add a first load case, primary. No problem with that. Everything by default. Add. And I'm going to create a self-weight load by default, factor -1, general y direction, perfect. Add, close. Then I'm going to click here. And I'm gonna assign 2 views, so the self weight will be applied to the whole structure. Perfect. So there you go. Everything is selected and everything has this self weight applied. And now we're gonna go for the mobile load. First, let's go to definitions, and here it's called vehicle definitions, but do not be scared by that, it's just mobile loads. So add. Now this screen appears. Here, if you're working with actual vehicles, then you can specify the vehicle depending on the ASHTO specification, or if you have a vehicle definition in a file, then you can import it. But as in this video, I'm not going to show you how to create vehicles by themselves. It's just mobile loads, but you can apply the same for vehicles. So I'm going to give the vehicle type reference 1 by default. The width of the vehicle, what does this mean? This means that you can work if this structure will be a 3D structure, so you can define the width. So let's say that if I had this truss duplicated in space, so I'm gonna close this for a second. So if I had something like this, -5, see, a double truss, and I would like to know, well, I would like to define a vehicle that is moving across those or on top of those trusses. Then if I know this distance, the width that I have defined as 5 meters, as you can see here, 5 meters, then in the vehicle definition I will be able to put 5 meters, yes, and the vehicle will be running along those 2 trusses. But I'm not going to do that because I'm working in a plane and to keep things easier. But again, as you have been able to see, it's really easy to modify the structure and create a 3D structure, and so on. That will be subject of another video. Okay, vehicle definitions, add. Then, as I'm working in a plane, so I'm gonna leave this as width 0. So that means that STAAD is gonna be only gonna be generating loads in the same plane. Here, well, the load, so it's gonna be 100 kilonewtons, for instance. Okay. I'm gonna create another one here, but with a load of 0. Why I need to do this? Because actually STAAD works with vehicles. So this is asking me the distance between the wheels. So this will generate a load of 100 kilonewtons here, and another load a meter from this load of 0. Again, if you are defining a current or an actual vehicle, then you have to define this distance to create, well, a series of loads. I could do that, but I just want to generate one point load. So at least you have to put a second value here. That's what I mean. Even if it's 0, STAAD will understand it. But if you leave this as a blank, it will give you an error. So let's add this. You can define multiple vehicles. I'm gonna leave it as just one, and that's done. Then, after having defined the vehicle, then you have to create a load case. So you have to go to commands, loading, moving load generation. This is asking me the number of loads to be generated. What does that mean? Well, after this screen, STAAD is going to ask me what is the distance between loads. So if I define the distance between loads by 5 meters, and then I define here the number of load generators to be 3, then the generation of, well, it's going to generate a point load here, then another one of 3 meters, 3 meters, 3 meters, and it's going to stop. So, as I know that this distance is 24 meters, 24 or 25? I think it was 24. 24. Then, well, it depends on how you want to generate the load. So let's say that you want to generate maybe one in the middle of each span, right? Or maybe not. Let's say 1, 2, 3, 4. I want 4 loads to be generated. Then you can define here if there is a predefined load to be added, but as load 1 is a self-weight, then I'm not going to use this. So I'm going to click add, close, and then I have to add the load. So I'm going to click add, and STAAD asks me what is the initial position of the load. So as I want to generate a load that goes from this point to the other one, I need to know what is the coordinate of this node, because it's the initial position of the load. How do I do that? So I can go to geometry, I click here, nodes cursor, double click here, and well, it tells me here what are the coordinates of that node. It also appears here, node 1 there, so 0, 3, 0. So I go back to loads, generate load, add, and then I'm going to put here 3. Then you can use this range. That will mean that it will generate loads in this direction, Y or Z. I'm not gonna use that because I just want to generate a load that goes from here to the other side. Then STAAD asks me for a load increment. That's what I was saying. What is the gap between loads? So let's say that this is 24 meters and this is a span of 6, well, every 3 meters, so it will generate one here, one at 3 meters, the other one at 3 meters. I've defined five generations, so I think so. So it will be 1, 2, 3, 4, 5. So yes, every 3 meters will be fine. I'm going to click add, close, and the load is generated. As you can see, here appears this symbol that shows me that the direction of generation is going to be that way. So everything should be working. This is the 1, 2, 3, 4. Yes, that's the load generation that we have defined here. I just defined 4. Okay, 4. Let's say 5. So it's gonna generate 1, 2, 3, 4, 5. Okay. Change, close, and then here I'll have 5 load generations. Everything's fine, starting from that point. Cool. So I'm gonna click. First, I'm gonna be sure, sorry for this, that the analysis is gonna be performed. So I'm gonna go analysis, perform analysis. I'm gonna select all, just in case. I think I had that done before from the first video, but just in case. Analyze, run analysis, yes, save. One warning, what's that mean? What is that warning? Oh, okay. That warning was showing me that exactly I defined it to perform the analysis in my previous video, so it's telling me, well, that you have asked me to perform the analysis before, so I'm gonna avoid the second definition of the analysis. That can easily be avoided by going to the file, the stat file, the proper stat file, and removing this line here manually. Delete, save, close. Thank you, stat. Well, after that error, sorry for that. Well, it will be stat who will need to apologize. Okay. Fine. Analyze, run analysis. Now, as you can see, 0 errors, 0 warnings, 0 nodes. That's what you want to obtain while doing this kind of analysis. Done. I'm gonna load all the different cases. Okay. And now I'm gonna click here and loads to see how the loads have been generated. As you can see, the first load has been generated at the node. The second load has been generated at the midpoint. Okay, yes, the third one is as it has been every 3 meters. It was like, okay, 0, 3, 3, 3, and probably that's gonna stop there. Good. What do we want to do now? It's just to check the results. A couple of things that you could do now. So I've kind of defined it not as I wanted, because I wanted more loads to be generated, not just those 3 or those 4. I could continue, but the load here is going to be the same as the load here. So actually, this is a better way to define the model, just half of it, and then understand that it's going to happen the same on the other side. So what you can do now is to click here, bending moments, and it will show you, well, go to beam, forces, bending moment is activated. You can see, well, you can see it now. I'm going to click here in loads to be able to see the load. See, when the load is applied here, nothing's happening to the structure. Basically there's a vertical load here, so everything is going to the reaction is going to be the same as the load applied. But if you go to load number 3, this has changed. See, when the load is applied here, again everything, well, I have activated just the bending moment, so that's why it's not showing the compression in this beam. But again, the bending moments on the other beams are pretty low, because remember that this was detached from the other beam, so it was only able to transmit axial loads. So load generation number 5, as expected, well, the point load is applied here, so you have a bending moment, and as expected, everything. Now if I click in shear forces, and if I go here and I deactivate the moments, again, well, this is working pretty well, this model. And then if I click on the axial forces, axial here, well, this is a little bit messy, but it's useful, because now I'm going to show you that when you get these kind of results that they are not to scale, what you can do is to go to symbols and labels, scales, you're checking axial, so if you add that 0 here, you will produce this. So as you can see, the whole axial force is going here, this is a plus, so that means compression, and those beams here are subjected to tension, and well, that's how it should be. All of these beams subjected to tension, 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 tension. This is in compression, compression, compression. And if I load the self-weight, as it could be expected, again, tension on the lower side of our truss. Good. Then now what I'm going to do is to recover the first part of the what we have done at the first part of the video, and it's to use the groups. So now if I go to beams, let's say forces, I'm going to go to summary, okay, and this is showing me for each beam the maximum moment, maximum or minimum, depending on the load generation. So this is saying me that load generation number 3 creates the worst moment. Where? This is saying node, but it should be, oh well, yeah, what is the difference between these two screens? Sorry for this. This is saying what is the maximum moment in a node, but as you can see here, the maximum moment doesn't happen in a node. It happens in the mid-span of the beam. So then you will need to go here, maximum bending moments, and then here it tells you really what are the maximum bending moments. So if I go here, so I'll need to check beam number 2, and the maximum bending moment actually is at position 3. This is the moment, so it's here, because this is 6 meters, so 3 meters from this point it happens the maximum bending moment. Good. So let's go with the groups. To use the groups, let's say that I just want to check, because here is showing me every single beam, and let's say that I'm only interested on this group of beams here for my analysis, for whatever I need to do. So right click here, right click, results setup, and here you can modify the load generations that are gonna be considered in your analysis. Let's keep all of them, and then in range, if I click group, it appears the groups that I created. So if I select upper beams, okay, then this window here is gonna only show me the results for those beams, as you can see here, beam 2, 7, 12 and 15. So I can focus my attention on just that analysis. If I, in a later stage, I want to check the lower beams, then it's the same. Right click, result setup, range, lower beams. And it's going to only show me 1, 4, 9, 14. 1, 4, 9, 14. And also here in this window here, it's only going to show you maximum, minimum bending moments and axial forces for those beams, or in particular, well, for those beams, but the nodes in those beams. So if I click Shift N, it will show me, and Shift B to remove the beams, it will show me that node 1 is subject to the maximum bending moment on that beam. So if I click on, and also, well, that bar in particular is the one that is being like force loaded in every combination. And that's it. Please practice this. If you're, of course, well, if you're watching these videos because you're interested, please practice this, groups and mobile loads, because they're a key to success. Well, I hope you have enjoyed it. Sorry for the delay on the release of this video, but lately I'm being quite busy. If you like this series, please let me know, because it's really important for me to know if, well, yes, you're really appreciating this work and if it's useful for you. So thank you, leave a comment, and see you in the next video. Bye.